We have traveled millions of kilometers in space. Voyager 2, launched in 1977, is currently about 20.4 billion kilometers from Earth. The geostationary orbit is 35,000 kilometers above the Earth's surface, where we constantly send satellites. The space above the Earth's surface is empty, making it easy to go up. However, it is difficult to go below the surface. Humans have only been able to reach a depth of 12 kilometers, which is very insignificant compared to the Earth's radius. Now the question is that we could not go very deep into the Earth's surface, but how do we know what is inside the Earth? Are we really going to reach the other end of the Earth if we dig a hole? Today's video answers such questions. In 1970, the Soviet Union began drilling the world's deepest borehole in Russia's Kola Peninsula, called the Kola Superdeep Borehole, which until now is the deepest hole in the world, through which people got to know a lot about the geology of the world. Microscopic plankton fossils have been discovered 6 km below the Earth's surface, providing insights into the origin of life on Earth. Additionally, studying the rocks in the deep layers of the Earth can help us understand the early conditions of the planet. When the holes were being drilled in the Kola Peninsula, various questions arose among the people. At that time, many believed that there were evil spirits in the depth of the Earth. Due to the hole in the Kola Peninsula, the evil spirits can enter the Earth, so there was a protest for the closure of this hole at the time. The temperature at the bottom of the Kola Superdeep Borehole, which is 12 km below the surface, was around 180 degrees Celsius. This means that the deeper you go into the Earth's surface, the higher the temperature gets. This is because the Earth's surface has cooled over time, but the bottom has not yet cooled. The Kola Superdeep Borehole was closed in 1995 and the holes were sealed. The diameter of this borehole was only 9 inches. That is, the mouth of the hole was so small that no man could jump into it, even if he wanted to. The depth of the Kola Superdeep Borehole is 12 km, which may seem huge to us, but it is very insignificant compared to the radius of the Earth. So now the question is, how do people know about the center of the Earth? Through earthquakes, we know what the interior of the Earth is like. An average of 55 earthquakes occur in the world every day. When an earthquake occurs, 3 types of waves are generated at that location: the S wave, the P wave, and the L wave. Among them, the S wave and the P wave are important. The P wave travels through compression expansion like sound with a maximum speed of 6 km per second. It can be performed through all that is solid, liquid, and gaseous. On the other hand, the S wave is like a light wave. Its speed is 4.5 km per second, less than the P wave, and it can only travel through a solid medium. When an earthquake occurs in any part of the world, the S and P waves generated by the earthquake are recorded at the seismic station placed on the whole Earth. Suppose an earthquake occurs in this part of the world, but the pattern of S and P waves received in different parts of the world will be the same. Note here that there is no P wave in these two parts, which is called the P wave shadow zone. Again, there is no S wave across this intersection, which is called the S wave shadow zone. Now the question is, why S and P waves are not found in certain places after an earthquake? We know the S wave can only travel through solids. Now one reason for not getting an S wave across this part is that there must be liquid material inside the Earth. And because the S wave cannot be conducted through this liquid, the S wave is not available across this specific part. On the other hand, a P wave is like a sound wave, and we know the speed of a sound wave depends on the density of the medium. After an earthquake, the P wave is reflected due to the difference in density of the matter in the center of the Earth, which is relatively higher on the opposite side of the earthquake. By analyzing the behavior of S and P waves, we can learn about the structure of the Earth's interior. Earth's core is not the only way to know about earthquakes. The S and P waves produced by underground nuclear bomb tests also reveal the center of the Earth. You may have a question. Numerous events are occurring above and below the Earth that cause a large number of waves. Now, how to distinguish the earthquake wave from the other waves? This involves a complex calculation known as a Fourier transform. Through this, all the waves in any complex wave can be separated. For example, suppose this wave is made up of 10 different waves. Now, you can separate those 10 waves by Fourier transformation. In this way, by analyzing the S and P waves obtained from earthquakes, we have come to know about the center of the Earth. There are different layers, like an onion inside the Earth. These layers can be divided into 4 parts. The very top part of where we live is called crust. Next is mantle, followed by the outer core, and lastly the inner core. The outer core is entirely liquid, and there is constant movement within it. This movement generates a current, which in turn produces a magnetic field around the Earth. The magnetic field acts as a shield, protecting the Earth from cosmic radiation. However, outer core is the position of the inner core where there are heavy metals like iron and nickel, and it is in a solid state due to high pressure. Its temperature is higher than the temperature of the surface of the Sun. Even at such high temperatures, it remains in a solid state due to excess pressure. Above this inner core is the outer core, which is made of liquid, and as a result of this liquid, the inner core is somehow separated from the Earth. So the movement of the inner core and the movement of the Earth are not the same. The inner core rotates only 0.4 to 1.8 degrees in 1 year, and many believe it rotates as much as 3 degrees. In the past year or two, there has been a lot of discussion about the rotation of the Earth's inner core. It all started with a research paper published on the Nature Geoscience website, which stated that the rotation speed of the inner core is decreasing, and it is also mentioned that every 70 years the rotation speed of the inner core slows down again. However, I have not found the article published by Nature Geoscience anywhere reliable that the rotation of the inner core will reverse or can happen. However, the rotation of the inner core has little effect on our lives, except for a minor shift in the day-night cycle. Now let's say whether it is possible to go from one end of the world to the other end. Firstly, it is not possible to drill holes along the center of the Earth, because the temperature will increase as you go down. The temperature of the Earth's inner core is about 6000 degrees Celsius, which is 9% higher than the temperature of the Sun's surface. No matter can remain solid at such a high temperature, so a hole along of the center of the Earth is not possible. But let's say you built a tunnel from this end to this end. Now what happens if you jump into this tunnel? Before jumping into the tunnel must be evacuated. Otherwise, you will be flattened by air pressure as you move towards the center of the Earth. Along with vacuuming, you must wear a spacesuit that protects you from the high heat of the Earth's core. Do all this correctly and you will reach the center of the Earth 19 minutes after the tunnel jump. And at that time, your speed will be 40,000 km per hour. Until you reach the center of the Earth, your velocity will increase, but after reaching the center of the Earth, your velocity will not increase, but then your velocity will decrease. Because after passing the center of the Earth, you will be working against gravity, which will cause your velocity to decrease. Thus, in 19 minutes plus 19 minutes, a total of 38 minutes, you will reach this exact distance. Now if you are not received for some reason, you will be swinging along the tunnel. There is a movie called The Core about the core of the Earth. Although the movie is not completely science-based, but in the movie you will learn a lot about the core of the Earth. It will seem to you that there is another world inside the Earth, where there is a sea of hot lava. Returning to Earth for astronauts in space is quite different from a typical plane landing. Upon re-entry, they descend through the Earth's atmosphere, often described as entering a fireball. For more detailed information, I recommend watching the following video.